Hello students, how are you? I am your RUPESH SIR speaking and you are watching your very own education channel Physics E-Mind. Today in this session we are going to deal with online tutorial 15, which is understanding graphs, last part. And in the previous session we have come across straight line and exponential graphical patterns, right? In today's session we will deal with other very important graphical patterns that we very often use in different applications in physics. Now, this is a small recalling for you and why we should learn this lesson, right? Now, first point is we will be able to recognize different graphical patterns generally used in physics. Number two, we will be able to understand different equations corresponding to different graphs which govern different physical phenomena as well as variations, right? Number three, we can easily switch between equations and its corresponding graph and vice versa. Number four, which is the most important point, here we are not trying to emphasize different coordinate geometry problems that you deal in mathematics in class 11. Rather, our actual aim is to build the basic understanding of different graphical patterns and their corresponding equations so that they are easily recognizable in different applications in physics and thereby can easily be implemented on a tailor-made or ready-made basis. Okay, students? So let us move forward. Number one is parabola. Today in this lesson we are basically dealing with different conic sections. Okay. So number one is parabola. What is a parabola? A parabola is a locus stretched out by a moving point on a plane following the condition that at each and every position on that locus the point is at an equal distance from a fixed point on that plane, okay, which is known as the focus as well as from a fixed straight line called the directrix. Have a look at this figure. Here at each and every position like P1, P2, P3, we are having the distance P1, B1, that is the distance from the directrix, and another point on the plane, that is focus, and the distance from that focus that is P1F, and we are having P1F equals to P1B1, P2F equals to P2B2, P3F equals to P3B3, and likewise. Okay, and here we are seeing different aspects of parabola, like this is focus, this is known as axis, and the point at which the parabola cuts the axis is known as vertex, and this is the directrix. Okay, students, let us move forward. So we can classify parabola in four types: type 1, 2, 3 and 4. Type 1 has its equation like y square equals to 4x. Type 2 has equation like y square equals to minus 4x. Type 3 is x square equals to 4ay, and type 4 is x square equals to minus 4ay. Remember always that in case of parabola we are having one variable in quadratic form and one variable in linear form. Okay, so in this table we are dealing with the equations and graphs of different types of parabola. So number one is type 1 parabola having equation y square equals to 4x, and here it is the graph of type 1 parabola, and here the opening is, you must remember that here the opening is in the right hand side, okay, in the right hand side, okay, and x equals to minus a is the directrix and f(a)(0) is the focus. Likewise we are having x equals to plus a is the directrix of type 2 parabola having equation y square equals to minus 4x, and here focus point is minus a0, okay, and origin is at point A. And type 3 parabola which has equation equals to x square equals to 4ay, okay, and focus point lies at 0a, and here opening is the upper end of the upper hand side of the y-axis. And in case of type 2 parabola we must say that the opening is in the left hand side, that is the negative direction of the x-axis. Okay, now in case of type 3 parabola, as we have said, the opening is in the direction of the positive direction of y-axis, and here directrix is y equals to minus a, and focus point lies at 0a point. Okay, now we are moving forward to the type 4 parabola, which is none other than x square equals to minus 4ay. We are having the graph pattern of this like that, and where the directrix is y equals to a, and focus point lies at 0 minus a, and opening is in the negative side of the y-axis. Here is an opening. Opening is in the direction of the negative y-axis. Okay. Let us move forward to the shifted parabola. It is found out by shifting the vertex of the parabola from the origin. If we shift the vertex of parabola from origin to another point like hk, then we will find out the shifted parabola. Okay. In online session 13, we have found out general equation of circle where the center of the circle has been shifted from the origin 0, 0. Okay. And it had been shifted to hk point. And this is just like the same procedure. For type 1 and type 2 parabola, the axis of the parabola remains horizontal as we have seen earlier, and if we assume the vertex is shifted from hk shifted to hk from the origin 0, 0, then type 1 parabola equation becomes y minus k whole square equals to 4a x minus h. The graphical pattern for which has been given like this. Okay, here the vertex is shifted from 0, 0 to xh. So from this concept we can easily draw type 2 type of shifted parabola. Okay, where the opening will be in the left hand direction. Remember that. And in case of type 3 and type 4 parabola, the axis of the parabola remains vertical, and if we assume that vertex is shifted to hk from origin 0, 0, then for type 3 parabola the equation becomes x minus h whole square equals to 4a y minus k. The graphical pattern for which is as follows, and from this concept we can easily draw type 4 parabola, shifted parabola also, right? Type 4 shifted parabola will be in the opening will be in the direction of the lower end of the y-axis, that is negative direction. Let us move forward to the ellipse. Okay, an ellipse is a conic section. It may be treated as a curve. It is a curve or locus traced out by a moving point on a plane which surrounds two focal points in a way that for all positions on that curve, the sum of the two distances to the focal points is a constant. Remember that always. Okay, basically ellipse is a general form of a circle. Now let us have a look at the figure where we are having different aspects of different parts of ellipse. Here we are having the center. These 2 points F1 F2 are the foci, and this part, the blue shaded part, is the semi-minor axis, which is the half of the minor axis. And from the center to the vertex, here we are having the semi-major axis, the twice of which it is, that is this vertex to this one, we have the major axis. Okay, so let us move forward to this picture, this image, where we are having that let xy be the point on any point on ellipse. Let us assume that d1 be the distance from minus c0 to xy, and d2 be the distance from c0 to xy. Okay, which are two foci, right? From the definition of an ellipse, d1 plus d2 will always be constant for each and every position of xy on the curve of ellipse, right? So let us move forward to the different standard type and corresponding equations and their graphical patterns. So first one is the type 1 type ellipse, and here we are having the horizontal ellipse. Number 2 is centered. This type of ellipse is centered at the origin. And number 3 is the major axis is on the x-axis. Let us have a look at the equation. The equation will be like x square by a square plus y square by b square equals to 1. You should remember like that. And here, as we are having over here, the major axis is on x-axis, right? So it is a horizontal ellipse. Okay, major axis, minor axis is this is semi-minor axis rather. So twice of the semi-minor axis will be the minor axis, and twice of the major axis, semi-major axis, that is the length of a, that is 2a will be the length of semi-major axis, and 2a will be the length of major axis. Okay, from this vertex to this vertex is major axis, which is twice a, which is twice that of the twice that of the semi-major axis. Okay, and these 2 points are the co-vertex as we are seeing over here. Let us move forward to the type 2 vertical ellipse, which is centered at the origin, and this is the standard type. Okay, in the case of standard type, we are having the center lies at the origin. Okay, here major axis is on the y-axis, that is why it is known as vertical ellipse. We are having the equation of this kind of ellipse like x square by b square plus y square by a square equals to 1. Here the minor axis is like this and major axis is, here it is the major axis, vertical axis. Okay. And this is the vertex. This is the vertex. Okay. Let us move forward to the center shifted ellipse. Here center is shifted from 0, 0 to hk. In this table we are dealing with shifted type of ellipse, type 1 and type 2. Having there also we are dealing with their corresponding equations and the graphical patterns. Let us move forward to the type 1 shifted type ellipse, which has the equation like x minus h whole square by a square plus y minus k whole square by b square equals to 1. Let us have a look at this type of ellipse, type 1 shifted ellipse. Here this is the ellipse that has the same type of type 1 standard ellipse. Only difference is that the origin, the center lies at hk, that is the center is shifted from 0, 0 to hk, and all other points like major axis is 2a, like the previous one, 2b, this is the length of the minor axis like the previous one. Okay, and here it is the type 2 type of shifted ellipse, having the center shifted at hk point. So we are having the equation of this type of ellipse is y minus h whole square by a square plus x minus k whole square by b square equals to 1. Here it is the type 2 type of shifted ellipse, having its center shifted from 0, 0 to hk. Here 2b is minor axis and 2a is the major axis length. Okay, let us move forward to the third one, that is hyperbola. What is hyperbola? It is a curve or locus stretched out by moving points such that the absolute difference of the distances from that point to two fixed points, which are known as foci, is constant for each and every position on that locus. Right? Here it is a pair of curves. Rather, hyperbola is a constitution of pair of curves. Here minus c0 and c0 are the foci, and the distances, the mode of the two, difference of the distances d2 and d1 always will be constant for each and every position of the point on that locus. Okay, and minus a0 are the vertex, and this x-axis is transverse axis. Okay, and this is the conjugate axis over here, y-axis over here. Okay, you should remember all these points. Please note it down on your copybook. Okay, let us assume xy be the point on the hyperbola. Any point we can assume. Let d1 be the distance from c0 to xy and d2 be the distance from minus c0 to xy. So we are having, then by the definition of the parabola, we are having, as we have already said, that mod d2 minus d1, that is the difference part, that is the difference of these two distances. Okay, and if we take the magnitude of that is mod d2 minus d1 is constant for each and every position xy on hyperbola. Okay, so different parts of hyperbola, as we are seeing that there are two types of mainly hyperbola. This is horizontal type and this is vertical type. These are the two foci, this point and this point. Here we are having two vertex, and this point and another point is here. Okay, this is the center. And as we have already said that here in this type of hyperbola, this x-axis is transverse axis, and along the y-axis we are having conjugate axis. Here this kind of vertical hyperbola we are having transverse axis is along the y-axis and conjugate axis is along the x-axis in case of vertical hyperbola. Okay, and this point and this point are the foci points. We are having center at the origin and vertex is at this point and this point. Okay, so here we are having in this table the different standard types of hyperbola that we are gonna deal right now. So type 1 type of hyperbola. So here, as we have said already, that this is the horizontal type of hyperbola having center at 0, 0. These two type of straight lines are known as asymptotes, right? Asymptotes of hyperbola, dotted blue lines. Okay, this asymptote have equation y equals to b by ax, and this asymptote has equation y equals to minus b by ax. So the slope of this asymptote is negative. right? Since it makes obtuse angle with the positive direction of x-axis, and the slope of this asymptote, that is b by a, is positive since this asymptote makes an acute angle with the positive direction of x-axis. Okay, students. So this type of horizontal hyperbola has its equation like x square by a square minus y square by b square equals to 1. Okay, let us move forward to the type 2 type of hyperbola, which is this is not horizontal hyperbola, this is vertical hyperbola. Okay, student, this is a minute typing mistake. You should remember that this is known as vertical hyperbola. Okay, not horizontal hyperbola. This is horizontal hyperbola, where the transverse axis is along the x-axis. Here transverse axis is along the y-axis. Okay, so this is the conjugate axis. Okay, so the equation is like y square by a square minus a square by b square equals to 1. So let us move forward to the shifted version of hyperbola. So here the center is shifted from 0, 0 to hk, and as we already know that these two dotted straight lines are known as asymptotes, as we have already seen in this figure, and these two are foci, and these points and this point are known as vertices. Okay, and the shifted type of the hyperbola, this type of shifted hyperbola has equation like x minus h whole square by a square minus y minus k whole square by b square equals to 1. This is type 1 type of shifted hyperbola, where the origin is shifted from 0, 0 to hk. Okay, and this is vertical hyperbola. This is vertical type of hyperbola, shifted hyperbola rather, vertical type of shifted hyperbola, where the center has been shifted from 0, 0 to hk point, and here also we are having two asymptotes over here, and these are two co-vertex, and we are having like the other ones, we are having also there are two vertices, and these point and these points are foci points. Okay, and the equation you should remember like y minus k whole square by a square minus x minus h whole square by b square equals to 1. Okay, here only remember that all remains same, only all the points like the non-shifted version, all the points will be the same, only the center has been shifted from hk to 0, 0 to hk. All the lengths will be also the same, only the coordinate will be different. So let us move forward to the special type of hyperbola, which is rectangular hyperbola. This type of hyperbola is known as rectangular or equilateral hyperbola because its asymptotes intersect rectangularly or perpendicularly. Okay, students, in this type of hyperbola, the transverse or conjugate are equal, so we'll have a equals to b. From type 1 hyperbola, what is type 1 hyperbola? X square by a square minus y square by b square equals to 1. Okay, this equation. Okay, x square by a square minus y square equals b square, y square by b square equals to 1. From this type 1 hyperbola equation we have already type 1 hyperbola equation we have already x square by a square minus y square by b square equals to 1. We have already seen it, right? Now if we put a equals to b in the above equation, that is this equation, right? X square by a square minus y square by b square equals to 1. If we are putting x to b over here in this equation, so we are having x square by a square minus y square by a square equals to 1, which moves us towards x square minus y square equals to a square. Okay, this is rectangular hyperbola form equation. Equation 1 is the equation of rectangular hyperbola as we are seeing over here. This is in this curve h1 and h2 are the rectangular hyperbola as we are seeing over here. Okay, students, the equation of rectangular hyperbola can also be written like this form, xy equals to constant. You should remember this form very carefully. Okay, students, we should remember this form very carefully. Here equation 2, that is this equation xy equals to constant, is the most extensive usage form of this type of rectangular hyperbola. Here this is OF. Okay, only OF. Foci lie on x equals to y line. Okay, here this type of rectangular hyperbola, foci lie on the x equals to y line. Okay, x equals to y line means it has slope 45 degree. Okay, and passing this straight line will be passing to origin as we have seen from the previous session. In different application, physics application, we use this type of pattern. Okay, suppose in case of Boyle's law in thermodynamics, okay students, it states that Boyle's law states that for a fixed mass of an ideal gas kept at a fixed temperature, pressure and volume are inversely proportional. Okay, so from this law we are having P proportional to 1 by V where T remains constant. Okay, you should write over here that T remains constant, pressure is inversely proportional to volume, keeping the temperature constant. So we obtain P equals to K by V, K being the proportional constant. So we are having PV equals to K equals to constant. This can also be written like P1 V1 equals to P2 V2 dot 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 equals to Pn Vn. Okay, at pressure P1 volume is V1, P2 at pressure P2 volume is V2 and likewise at pressure Pn volume is Vn and likewise the temperature must be kept as constant. Okay, so isothermal process. Okay, isothermal process means the process at which the temperature must be kept as constant. Okay students, please remember that. So variation of pressure with volume must be rectangular hyperbola as we have seen in Boyle's law. Okay, so this is the variation of rectangular hyperbola in case of Boyle's law. The graph shows the variation of pressure with volume V keeping temperature fixed. Number 2, the graphical pattern is of the form of rectangular hyperbola. You should remember this type of hyperbola. Okay, so it is very, very important as far as your different examinations are concerned. Okay, students, that's all for today. We'll be meeting very soon in the next session. Till then, bye. Keep studying. Stay safe. Stay home. Okay, students, bye.